Okay. See you Wednesday? Right. Okay, with the fundamental theorem calculus, what we're going to do is look at, well, how do we, what does it use, what is it used for? How do we find what we're looking for? And what are the procedures? And there are two ways we can do this. The fundamental theorem calculus is how to find the net change of a function. Over an interval. Remember what the mean value from algebra, what it was? What is the mean value? Well, the mean value in algebra, what it did is this. If I have a function at A and B, if my f of A and f of B have different signs, then I'm assured that there's a point somewhere between A and B where it equals 0. That's the intermediate value. The mean value now goes for the average value. This is the intermediate. And this is going to be important for us because whenever we have graphs on both sides of the equal sign, the x-axis, we have to separate them up. So the average value, which is the mean value, is what we just found. It relates to what we just found, I should say. This is what it's used for. So instead of finding the area under a curve like this, I could find the average value, the middle number, the mid number, where I can take that area, call it number C, and that's going to be my f of C times delta x. And it's going to give me the same area as using what we were using the Riemann sums or the integrals. The mean value, again, the mean value says I can find the value somewhere inside the interval AB that when I take the f of x of that times the width of it, so f of C times the width of B minus A is going to be equal to the integral from A to B of my function. Everybody understand that? There's, instead of looking, since the function itself is going to be all wonky and stuff, I can find a value and make a rectangle that has the same area as that wonky graph. But if we look at it one step further, How does this equation relate to this? If I divide both sides by b minus a, I got the average value theorem now. That's what we just have here. That's what we just spent time looking at. So this is how the two relate. Here's a theorem. The mean value theorem for definite integrals. If f is continuous on a closed interval AB, then at some point C in that interval AB, the value of f of C has got to equal the average value of our function. So f is continuous on the closed interval AB, and A does not equal B. And if the integral f of x from A to B, if that equals 0, then f of x equals 0 at least once in the interval AB. Show that f is continuous on AB and that A does not equal B. And if the integral of AB of f of x equals 0, then f of x equals 0 at least 1 point. And this is leading us to what's happening in a very, very near future. So how do we start this? As we were just been talking about, if the integral exists, that means we have to be able to find an average value of f, which is 1 over b minus a. So do we know what b and a are? No. Do we know what the integral of f of x is? 2. If it equals 0, then the whole thing is 0. So the only way that can be true by the mean value theorem says that f is some point at a C inside the closed interval AB. So at f of C, if it equals 0, then the integral equals 0. Why? If f of C equals 0, Because of this, so does all this. And since A and B are not equal, this can't be zero. If it equals zero, what has to be true? This has to be zero.
Yes.
If this is true, that means this cannot equal zero. It can't, because B minus A have to be different. So the only way this can be zero is if the integral is zero. What's the only way the integral can be zero? Well, we're gonna find out here in a second is that if we take the integral and part of it's on below the x-axis and part of it's above the x-axis.
In different signs?
If the opposite signs, right? Yeah, and that's what we're gonna look at in a second. Now we're gonna look at this in two parts. The fundamental theorem of calculus, part 1. Finding the antiderivative. What is an antiderivative? That's just another name for integral. Because anti means the opposite. The opposite of a derivative is the integral. So when I find the antiderivative, I'm finding the integral. We do this by 1. Taking the limits of finite sums to get the definite integral. And the second way is so to find this, we do it two ways. Let's just skip straight to that. What this is saying, for that to be true, the derivative of f of x of this function is equal to the derivative with respect to x of the integral of a to b, a to x. Yep, now we have to define that value. So what we're looking for is this. Remember what I said earlier, that when we take the integral, what is this number inside here? That's actually the derivative. Because remember, if I had x squared, what's the derivative of x squared? If I take the derivative or integral of 2x, what would I get? There's the 2. What's the power? 1. Add 1 to it, and then divide by it. So whenever you take an integral, you're taking it of the derivative of the original function. Integral says I have the derivative what is the original function? That's what the whole thing's about. Now, don't just read out there. I want you to understand what I'm saying. Whenever you take the integral, this function here is actually the derivative. What you're finding is the original function. So that's what this is saying. So the derivative of a function is the same as the derivative of the integral. What that's going to finish is going to give you f of x. As long as you're going from a to x, the derivative of it with respect to x, what happens is it just becomes f of x. Okay, that means nothing until you see it in action. Example 2. 1. If y equals the integral from a to x of t cubed plus 1 dt. With what we just talked about a second ago. Are my bounds from a to x? Yes. So what that means, if I take the derivative of this thing with respect to x, I get x cubed plus 1. That's my answer. Because this value goes in place of that. And that's your answer. As long as you're going from a to x. Okay, I can ask you why, but you're going to sit there and stare. Because the derivative of the integral, that's what we're looking at here, the derivative of the integral is simply the function at that x. Only if it's a to x. If it's not a to x, we have to arrange it algebraically. For example number 2. If y equals x to 5, 3t sine t dt. What's the answer? Is it in the right format? Is it going from a to x? No, it's going from x to 5. So what do I have to do first? I got to switch them. When I do that, I got to change the sign. Now that I'm going from a to x, all I got to do is put x in place of t, and there's my answer. And third one, y equals integral of 1 to 2 cosine t dt. Oop, that's x squared. So there's a problem here. What do we notice? We're going for x instead of x squared instead of x. So we have to use substitution. Instead of going to x, we're going to say that u is equal to x squared. So now we're going from 1 to u. And u is x squared. But now since I'm going to u, how do I take the derivative of this? What's the derivative of u? 2x dx. So what I have here is the derivative with respect to u of my integral from 1 to u cosine t dt, which become times the derivative of du. Do I have a 2x in there? So with my du is 2x dx. What's the integral of 1 to u cosine t? What's that integral? Remember, the derivative and derivative and integral cancel each other out. So we just get cosine t. But it's going to u. So that becomes cosine u. What is du? Du is 2x. So our final answer is 2x cosine. What is u? X squared. And there's my answer. Because we're not going, you can't go to anything with a power or exponent or a radical, rational. We have to go from a to x. So we change it to u. We have to find du because when we take the derivative of the integral, we have to have du in there. Du is 2x.
What if we do X squared?
Well, that's what u is.
Oh, okay.
When we change this, it becomes cosine u. And last one, d, before we move on. D is integral of 1 plus 3x squared to 4 of 1 plus 2 plus e t dt. Next one. Then we'll get to the next, which is the one we're going to be using more often. So how do we set this one up? What we're looking for, we're looking for the derivative of, well, first off, is this right? We have to do, you said what? Change the sign. So then it becomes 4 to the power 1 plus 3x squared, 2 plus e to the power t dt. Then what? We could do the u du again. If we say u equals 1 plus 3x squared, then du is 6x. So we got the negative. The derivative of the integral is just this 1 over 2 plus e to the u du. So this becomes negative 1, 2 plus e. What is u? U is 1 plus 3x squared. And du is 6x. So the answer becomes negative 6x over 2 plus e. It's exactly the same way we just did the last one. So remember, whenever you take a derivative of an integral, it's just change whatever that is to the u. So this one should have been 1 over 2 plus e to the u. U is that upper bound, and du is that. Just multiply them together. Now things are going to get easier. Fundamental theorem of calculus part 2. And this is the way you're going to be doing most of your integrals from here on out. Remember, f is continuous on the closed interval AB, and f is any antiderivative of our function on that. Then we're going to look at our integral f of x dx is equal to the upper bound minus the lower bound. And this is what we're going to do most of them from now. This is the one we're going to do most of them from here on out. Example 3. A. From 0 to pi, cosine x dx. What is the integral? What is the definite integral from cosine x from 0 to pi? So what's the antiderivative of cosine? Do your circle? I mean, just staring at it's not gonna make me happy with anything. What's the antiderivative of cosine? Sine. But remember, sine, cosine, negative sine, negative cosine. And we're going backwards. So the integral of cosine is sine from 0 to pi, according to this theorem, part 2 fundamental theorem, is sine of pi minus sine of 0. Sine of pi is 0, sine of 0 is 0, so the answer is 0. Integral from negative pi over 4 to 0 of secant x tangent x dx. So what's the integral of secant x tangent x? Look at your charts. Don't guess. I don't like people guessing in my classes. You can never guess in a math class. It wouldn't be math if you did. It's secant x. So then we take secant of 0 of the upper bound minus secant at the lower bound. Secant is what in sine and cosines?
1 over.
Cosine. So 1 over cosine of 0 is 1. 1 over 1 is 1. 1 over cosine. Cosine being negative pi over 4. What's cosine of negative pi over 4? It's in the fourth quadrant. Cosine is positive, so it's square root of 2 over 2. Since that's on the bottom, we got to flip it. So we get 2 radical 2. Rationalize it. We get 2 radical 2 over 2. And there's your answer. Again, you have to review your trig identities and your algebra skills. Since it's secant is 1 over cosine, cosine of pi over 4 is radical 2 over 2. 1 over radical 2, flip it, and then rationalize it. Do a couple more, and then we'll call it a day. The integral from 1 to 4 of 3/2 radical x minus 4 over x squared dx. I don't know how you're doing this stuff without writing anything down. Use the addition subtraction properties. The constant goes out in front. And radical x is x to the power 1/2. The 4 goes out in front. And since that's on the bottom, we get -2. Add 1. So it becomes x to the power 3/2 over 3/2 from 1 to 4. So add 1, so it's -1 from 1 to 4. We have the coefficient, take the bottom, it becomes 2/3. X to the 3/2 from 1 to 4. -1 over x from 1 to 4. Those cancel. That negative and that negative becomes a positive. 4 over x from 1 to 4. This first one, we take it at the upper bound, so it's 4 3/2 minus the lower bound, 1 3/2. Take it from the upper half, in place of x, put a 4. Minus, put a 1. What is 4 to the power 3/2? Without a calculator, you don't need this. You're supposed to be in calculus. You should know algebra. 8. 1 to any power is 1. 4 divided by 4 is 1. Minus 4. 7 minus -3. It equals 10. Couple of more. D. Integral from 0 to 1 of dx of x plus 1. What's this one going to be? You've seen this one before. Or if you want to, you could put it as 1 over x plus 1. What's the integral of 1 over x? Ln x from 0 to 1. When x is 1, we have 1 plus 1 minus when x is 0, 0 plus 1. So ln of 2, ln of 1. I don't need the absolute value signs. Ln of 2 is ln 2. Ln of 1 is 0. So the answer is ln 2. And the last one. 1 over x squared plus 1 dx. We've done this a couple of dozen times also. The integral of 1 over x squared is the inverse tangent of x from 0 to 1. So that gives us the inverse tangent of 1 minus the inverse tangent of 0. Inverse tangent. What angle makes tangent equal to 1? So where do sine and cosine have the same values? Pi over 4 at 45 degrees. What angle makes tangent equal to 0? Tangent is sine over cosine. What angle makes sine equal 0? 0, pi. But pi makes it negative when we say in the first quadrant, so that's going to be 0. Pi over 4 minus 0 is pi over 4. Yeah, we'll just pick up from here next time because we're going to look at these rules and move them around. Yeah, basically, which somebody asked earlier, I forgot who it was. If you think about it, if we had a graph, let's look at the sine and cosine. At 0, this is a sine function. From negative pi over 2, pi over 2. If I asked you to find the area of the curve from negative pi over 2 to pi over 2 of sine x, what's the integral of sine x? We just talked about it 10 minutes ago. What's the integral of sine? Negative cosine. Because the derivative of negative cosine is sine. It's going backwards. From negative pi over 2 to pi over 2. So I have negative cosine pi over 2 minus negative cosine negative pi over 2. So cosine of pi over 2 is what? I don't see what you're looking at. You can't see it in the air. You should be drawing pictures and see what the unit circle looks like. I don't know what you guys are trying to, who you're trying to fool here, but you can't find it in the air. Cosine deals with the x values. What's the x value at pi over 2? On a unit circle? 0. And likewise other, so it equals 0. The problem with this is because part of the graph is below there, that's negative area, and this is positive area. If I add these two together, they cancel each other out. And that's what this tells me. So what I would have to do inside this domain, find out, does sine x equal 0 anywhere here inside that domain? Sine x equals 0 at 0. So I would go from negative pi over 2 to 0. and then from 0 to pi over 2. And take the absolute values of those. So the integral of sine x is negative cosine x from negative pi over 2 to 0. And I want absolute values. Plus negative cosine, plus negative cosine x from 0 to pi over 2. Whatever value I get, I'm going to drop the negative. So I have negative cosine of 0 minus negative cosine of negative pi over 2. That's the first part. Then I add them. I get this side. Negative cosine pi over 2 minus negative cosine 0. What is cosine 0? Again, yes, 1. Cosine pi over 2. 0. Cosine pi over 2 is 0. Cosine of 0 is 1. So on this left side, I have negative 1, take the absolute value of that. And this positive 1. So it's 1 plus 1 equals 2. That's my area under my curve. If you ever take the integral and it gives you 0, that tells you that there are equal sides on top and below the x-axis. What you have to do first, if I give you a function and the area, the integrals from negative pi over 2 to pi over 2 of sine x equals 0. If it ever equals 0, then you know you have an intercepting point. Take your function and find out where it equals 0. And then at that point, that's when you have to take the lower bound to 0 or wherever that value is. But we'll talk about that next time.